So this will take us toward reliable pumps. This is me. My name is Larry. My last name is Backus. Everything that we own, think of your car, your computer, that gives good service, maybe your watch, your cell phone. Everything that we own that is reliable and gives good service has proper design, proper application, proper operation, and proper maintenance. Think of your power tools, think of your refrigerator and your TV. Likewise, reliable pumps also exhibit or possess proper design and application, proper operation, and proper maintenance. And everybody, that means design, operations, and maintenance, must contribute to reliability. If one of the elements is absent or incorrect, one of these four, design, application, operation, or maintenance, then the reliability chain is weak. And you can see the weak link in the chain. That's the link that's going to break. Here is an example of inadequate maintenance. It is a pump that is in the shop because of inadequate maintenance. Now the shop fitters install bearings. Here's a bearing. That is called the inner ring or the inner race of a ball bearing. It failed prematurely, and the question is, what is the problem? We can see the problem. The wear path, that's this darkened area right here. The wear path is not parallel to the groove, to the race. It oscillates through the raceway of the rotary ring. That bearing absorbed misalignment at the shaft and the bearing housing. So the shaft must be perfectly seated and perpendicular to the housing. And if the shaft is cocked like this, or if the housing should be cocked like that, then it's going to lead to this failure. Now this is something that happens in the shop. The mechanic who installed this bearing installed it wrong. It leads to premature failure after a few weeks or even a few days of service, and the pump is back in the shop again, being rebuilt again. Now, many plants have vibration analysis. Raise your hand if you do vibration analysis where you work. Most places do these days. So vibration analysis will indicate the misalignment. Many places do oil analysis these days. They will send samples of the oil to the laboratory, and they will say there's copper or iron or stainless steel shards, microscopic shards in the oil. So this is why we do oil analysis, all in an effort to determine what's going wrong with the equipment. A lot of vibration analysis and a lot of oil analysis is simply monitoring the progressive degeneration of the equipment, but not doing anything to correct it. Just monitoring the progressive degeneration of the equipment. This failure will repeat itself for years, even with the most expensive vibration analyzer and with the most sophisticated oil analysis. You won't resolve this failure, you won't make it go away until the shop fitters and the shop engineers learn their contribution to reliability. Everybody must contribute to reliability. So in this particular case of the bearing, design and application and operation is good. The weak link in this chain is maintenance. Something is going on in the maintenance shop that's causing this bearing to be installed misaligned to the housing. This means the shop engineer should be on top of the fitters. If you've got numerous tables in the shop where the equipment is being repaired, and the shop engineer ought to constantly be walking around the tables and talking to the mechanics, the fitters. Now, the fitter ought to be asking questions of the shop engineer. What I find is that many shop engineers will go into the heated and the air-conditioned office and leave the mechanics out there in the weather, in the heat of the summer and the cold of the winter, doing their job, and the shop engineer and the shop mechanics never even coincide. They don't even meet. They don't even cross paths. Now that's a shame. This is a failure in leadership. Everyone must contribute to reliability. It is impossible to assign 6 or a dozen young engineers to be the reliability team, give them each a vibration meter, and then expect them to bring about a significant improvement in the pumps in a refinery or a power plant or a chemical process plant. This is going to take us toward reliable pumps. This will be a guide to stop rebuilding pumps.